All right, y'all, this is day 2, and we are going to be hitting on the response and explanatory variables again. Okay, this was something that we touched on for like a day in chapter 3, and most people bombed it on the test. And then we had it again on the 9-week test, and it was bombed again. So hopefully the third time with this is going to be the charm. Anyway, all right, y'all. So let's go ahead and get started. We'll talk about blind. That was a vocabulary word that we had back when we were doing explanatory and response. But a subject is blind if he or she does not know which treatment he or she is receiving. Okay, so just keep that in mind. Here is the experiment. I'm gonna read through it, and then once we flip over to the next screen, this is where we'll do our explanatory and response variable. All right, so the place kicker on a high school football team notices that he seems to kick the ball farther when the weather is warm compared to when it is cold. Of course, as always, there could be several reasons for this different. Maybe his leg muscles are looser when it's warm. Perhaps the ball has less resistance as it moves through the air because it's not as dense when the air is warm. The warm air is thinner. Alternatively, perhaps the air inside the ball is warmer, which increases the pressure and makes it kick better. Okay, so any of those could be the determining factor. But we want to see if he can kick the ball further after it has been heated up compared to when it is cold. All right. So the explanatory variable, remember that is what is being changed or manipulated in some way. In this particular problem, that is the temperature of the ball. That is your explanatory variable, the temperature of the football. Okay, that's the temperature of the football. Now, a lot of y'all, and I didn't put this on here, but I want you to go ahead and make another spot right here for the treatments, and we'll come back to it in a minute. Okay, so the treatments are sometimes a lot of you mixed up treatments and explanatory variable. Okay, so we'll talk about that here in just a minute. But the temperature of the ball is the explanatory variable. That is what is being manipulated. We're going to heat the ball up, or we're just going to kick it cold. The response variable, okay, that one's kind of self-explanatory. The response is like, why are we doing this experiment in the first place? Well, we're trying to determine, does the distance determine the distance that the football is kicked, is it determined by the temperature of the ball? Okay, so your response variable is the distance that the football is kicked. Okay. Now I want to go back to the treatments. Okay, so treatments is always directly related to what it is that is being manipulated. Here it's the temperature of the ball. So our treatments is going to be a warm football. Okay, because remember we're going to heat it up. Warm football and cold football. Warm football and cold football. So that is the difference in the explanatory, the response, and the treatments, which you are always usually asked for, and I'm surprised I didn't put it in here. All right, so randomization. All right, y'all. So that's where randomization is where we're gonna, kind of spell out how we will randomly conduct this experiment. All right, so if you flip on over, I'm going to pull this up over here. So if you flip over, you can see how the experiment was carried out. So for his distance with the warm football, there's 1, 2, let me point these out to you. There's 1, 2, 3, 4, 5 trials, and then for the distance he kicked with the cold football, there's 1, 2, 3, 4, 5 trials. So when I am writing out my randomization over here, I want to have looked ahead and see, you know, how was this experiment actually carried out. So based on that, I'm gonna say that I will randomly select 5 footballs to heat up in some way. Like maybe I'll I don't know, maybe I'll just let them like set out in the sun. Okay, so yeah, I'll put that in parentheses, set in, you know, the sun for an hour. Okay, just, you know, as specific as possible. So I'll randomly select 5 balls, I'll heat those up, then I will randomly select, and I'm just going to keep this going. Randomly select 5 footballs to heat up, and randomly select 5 footballs to, maybe I'll put them in a freezer for an hour, to place in freezer for an hour. All right. So that's how I would just, you know, make sure that both of them, or both sets, one set was heated, one set was cooled, and then, you know, start my experiment. Okay, so that's randomization. Variables controlled, and oh my goodness, there's so many things to control. If you think of one while you're watching this video, you want to ask me about it, please ask. I am going to, I made a list so I didn't have to just sit here and say a million more times. So I'm gonna put my list up here, and then if you think of anything else, of course, there's again, add it to your list. Maybe run it by me. This is what I was thinking though. Same initial air pressure. Okay. Of course, make sure it's the same size. My son played football this year for the first time, and he had a different size football than I think is, you know, like a standard NFL, or probably even that the high school players use here. Okay, so same kicker, that's important. Weather is important. We obviously can't control the weather, but you know, if this experiment is being conducted in Georgia, y'all know how fast our weather conditions change. Weather, let's do field conditions. Oh, y'all, I'm sorry. I know this banging on the board is probably really annoying. I'll stop using this stylus. What about the holder? You know, the person that holds, or you know, if it was a tee, even maybe he was just kicking off the tee. What kind of shoes he's wearing, cleats or no cleats. Okay, so those were a few that I thought of, and if you think of anything else, then of course, by all means, probably a good idea to control as many things as possible. Alrighty, so blind, why or why not? Why or why not? So that goes back to that first definition, and here I would say that we would be blind, because blind would be that, in this case, that the kicker doesn't know whether he's kicking a heated up football or he's kicking the one that's been in the freezer. He's not going to know because he's wearing shoes, and then whoever is holding it, or you know, we would just have someone else to put it on the tee. So I would say this one would be blind. The reasoning is that, you know, it's not critical information that the kicker knows if it's been heated or not. And if he knows and is feeling like, one way or the other may be the better outcome, maybe if he's kicking the heated ball or maybe he's kicking the cooled down ball, whatever. But he may have a bias one way or another and actually try harder when he knows that particular scenario is coming up. So I would, anytime that you can make your subject blind, not let them in on, knowing which treatments they're getting, that usually gives you better results, less bias anyway. So I would say blind because the kicker doesn't need to know the temperature of the football. Okay. All right. So now for the simulation. So I don't know if y'all have noticed, but here lately all of our simulations have been note cards. So I'm gonna stick with that. So we're using, let's see, what did we say? 5 and 5. We said five heated and 5 cooled down balls. So let's say using 10 note cards, I will write the distance the football was kicked on each card. Shuffle the cards all together. And randomly deal into 2 piles. One pile for the heated, and one pile for the cold, or the one that we put in the freezer. Find the mean. Okay, remember this chapter is about finding the mean and finding the median. Find the mean of each pile of cards or each stack. Find the mean of each pile and then subtract. Let's go back up here real quick and look at this just so that we know what our original hypothesis was. So he seems to think that he kicks better, or he can kick farther when the weather is warm compared to when it is cold. So that is very important for us to go back and remember when we're writing out how we would simulate this. Okay, so when I go back here, subtract what? Subtract the warm average minus the cold average. Okay, because in the original scenario, the kicker thinks he does better when it's warm as compared to when it's cold. So that's how you want to set it up. This right here, this is going to end up being how you figure out your test stat. Okay, that's going to be your test stat. Okay, so now record these differences. I'll say this difference because we're doing this once. Record this difference on a dot plot. And repeat this process many times, maybe 99, maybe 9,999. Okay, so 10 note cards, that was for the 5 footballs and 5 footballs that we saw over here.